Hey everyone, and welcome back to edritt. In this lecture, we are going to study about binary number systems. So without wasting the time, let's start. So binary number system. So in this number system, the radix r is equal to 2, which means it has two symbols. Now what are those symbols? They are 0 and 1. Okay. Now in the previous lecture, we saw an example where we saw 786 has three symbols, sorry, three digits in that, which is 7, 8, and 6. Similarly, if I say an example of 101, here also I have three digits, which is 1, 0, and 1. Okay. Now, what now? This each digit in case of binary number system, we call each digit as bit. Okay. And in binary number system, 4 bits, we call them as one nibble. Okay. And you know, 8 digits, sorry, I'll say 8 bits is something which we call as two nibble. More interestingly, we generally term them as one byte. Okay. Now you see this 8 bits is equal to one byte. Now, do you recall how your internet provider provides you the speed number? This says something like, let's say 32K small bps. Now, this sounds like a great number, right? But let's try to understand what it actually means. So this 32 kbps is in bits. We need to convert that into bytes. So we have to divide that by 8 because 8 bits is equal to 1 byte. So this comes as 4 kbps, capital BPS. So the actual speed, the relevant speed offered by that internet provider is this, while as this is something we can call as marketing. Now again, let's try to understand what sort of uh, what's how many numbers we can create based on an n bit binary numbers. Okay, how many combinations which we can create using an n bit binary number. So let's take an example where I have three spaces available. Now what this symbol space can take, this can take 0 or 1. Again, this can take 0 or 1. This can also take 0 and 1. And decimal is the only case where 0 we cannot take for the MSB, so the MSD, but other cases we can take 0 as well. So, here two symbols are possible, two symbols are possible, two symbols are possible, 2 raised to power 3. Let's see another example where I have five places to put in. Here again, I can put 0 to 1. Here again, I can put 0 to 1. Here 0 or 1. I can put 0 or 1. I can put 0 or 1. Again, here two combinations, 2, 2, 2, 2. So in total, five combinations are there. 2 raised to power 5. Now here you see the number of symbols. If I denote as n, they were 3. Here the number of symbols which I can denote were 5. For n bit binary number number of combinations possible will be equal to 2 raised to power n. You put n equal to 3, you get this number. N equal to 5, you get this number. So this is how we can note this formula down. So this is all for this lecture. In the next lecture, we will see what are octal number systems. Thank you. Hope to see you in the next lecture.